Okay, welcome back. I'm calling this lesson 4.x. What we're going to be doing now in the next 4 videos is just word problems, word problems, word problems. This one is, I'm calling it type 1. It's the fencing type question. We saw one of these already, so let's do another one and see what we end up with. Good strategies for these is always draw a picture and keep all of your knowns listed nicely so you know what each variable stands for. So Maria has a 25 meters of fencing with which she wants to make a rectangular garden. Okay, so right there, draw a rectangle. Now, she will use her house as one of the sides of the garden and fence for the other 3 sides. So right away, what we could do here is we could erase one of the edges. So her perimeter is only going to consist of 3 sides. So 2 of the sides are going to be the same, and this other longer side is going to be different. And for those 3 sides of fencing, right here, she has a total of 25 meters. So the perimeter that she has is going to be, let's call this X, let's call that X, and let's call that Y. It's going to be made of 2X plus Y. And she has a total of 25 meters to do that with. We care about maximum area. Now, the formula for area is X times Y, or length times width. Now we have 2 variables, which is a bit of it's a problem. Well, it's nice to just work with 1 variable. So how about we take this perimeter equation right here and we solve it for one of the variables. How about we solve it for Y? So let's take this over here, solve it for Y. So Y equals 25 minus 2X. All right. Now we have this in terms of only X, and I can take this Y and replace that Y with this 25 minus 2X. Okay, so let's rewrite our area equation with X, and instead of the Y, I'm going to put 25 minus 2X there. All right. Now, while we're doing this, we should also remember that X is, we could call that our width. So let's just keep that over here. So, whoops, that's our, we'll call X our width and Y our length. And now let's multiply this quadratic through here and rewrite it so that it looks like an x squared plus x plus constant thing. Okay, rewrite that so you have your a term out in front, giving us minus 2x squared plus 25x. And we want to know what is going to maximize this right here. Now for the maximizing questions, we notice that we are going to end up with an a value that is negative, which means we have a quadratic that is going to be upside down. And our maximum is going to occur right here at the vertex. And if you recall, the easy peasy lemon squeezy way to find the vertex is to use our little equation, which is x minus b over 2a. Now, our b value here is 25, and our a value is minus 2. So this gives us that the x value of the vertex is 25 over 4, and now we can use this to figure out our y. So if you recall from above, we had y was equal to 25 minus 2x. Let's plug in our 25 over 4 in place of the x. And we end up with a value of y being 12.5. Now, here is our x and our y values. So we can say that our width is 25/4 meters, which is 6.25 meters. And our length is 12.5 meters. Now, if you were asked the maximum area would be 6.25 times 12.5 meters squared. So this gives us a maximum area of 78.125 meters squared. Okay. So now our next question is very similar, and it involves a parking lot that needs 3 sides fenced, and you have 400 meters of fencing available. And the final question here is, what is the maximum area of the parking lot? So since this is very similar to the first question, I want you to try it, press pause, try it, and then I'll show you the reveal in a minute. All right, so here it is for this question. You've got a parking lot. You only really care about 3 sides that are going to be fenced. So the perimeter of that is going to be 2x plus y. And this is x, and that's y. And all this together is going to be 400. Now, to figure out the area, that's x times y. And now we've got to rewrite this equation right here so that it's in terms of y. And that's so that we can write our area in terms of just one variable. So we've done that there. You end up with x times 400 minus 2x. And that, when you distribute the x through, we end up with 400x minus 2x squared. Rearranging that so you have your a term in front, you end up with negative 2x squared plus 400x. And using our x equals minus b over 2a to find the x value of the vertex, we end up getting that the x value of the vertex is 100. Now, if x is equal to 100, then what is y? Y is going to be this length over here, right? So you've got this y over here. We need to figure that out. We use our equation that we had earlier of y is equal to 400 minus 2x. Substitute our x as being 100. We end up with y equals 200. So now this tells us that our fence would be 100, 100, and 200. And if you add all of those up together, you get 400 meters of fencing. That's great. So now what's our maximum area? Our maximum area that we get from here is 100 times 200 meters, which gives us the result of 20,000 meters squared. And there you have it. That's our max area. All right. Hope this helped with the word problems. Again, try questions. You have to practice, practice, practice. Good luck.